Today we'll be looking at lesson 3.5 on arithmetic sequences and writing them as linear functions. Okay, so there's a lot on this page here, but highlighting, we're going to look at arithmetic sequences, and the definition of those would be a numerical pattern. So it has numbers that make a pattern. It can either increase or decrease, but it's a common rate every time. They also call the common rate a common difference. But it doesn't necessarily have to be difference, it could be addition as well. So this is the equation that we will use to write an equation for an arithmetic sequence. It will also help us to find different parts, so it may help us find the term, let's say the 100th term in a sequence, without actually having to do the pattern 100 times. So this will help to be able to figure out the numbers that are far away, basically. So this is the equation. Specifically, the title for it is the equation for finding the nth term, and each part has a different meaning. So a sub 1 is going to mean the first term in the sequence, and then n usually is going to stay as n because you're trying to find what number of the term it is, and then d is going to be the common difference or the pattern. So we're going to work with that in a little bit. First, we're going to figure out, to determine whether each sequence is an arithmetic sequence or not. So we're looking for a common rate between each number, either increasing or decreasing. So we need to figure out how to get from negative 26 to negative 22. So I usually always start with addition and see if I can add by a certain number. So negative 26 plus 4 is negative 22. So we're going to keep that in mind and see if this continues. Then we have negative 22 to negative 18. And again, that's going to be plus 4 to get from negative 22 to negative 18. And then again, we have from negative 18 to negative 14. And that's also going to be plus 4. So we can say yes here that this is an arithmetic sequence because it has a common rate or a common difference. Here's another sequence that we need to think about. So if this is going to be how you get from 1 to 4, let's start with addition. So we would add 3, but then we have 4 to 9. That's going to be adding 5. And then we go from 9 to 25, which is adding 16. So this does not actually have a common pattern, okay, meaning the rates here are not all the same. So I would say no, because it does not have a common rate. Here we're going to think about, again, trying to come up with the next terms of the arithmetic sequence, so we have to figure out the pattern. So we go from 9.5 to 11. Again, I always start with addition. So to get from 9.5 to 11, I have to add plus 1.5. Then I'm going to go from 11 to 12.5. That's also adding 1.5. And then finally I go from 12.5 to 14, which is again adding 1.5. So if I need to come up with the next 4 terms, I'm going to just keep adding 1.5 and list the next 4 terms, which are going to be 14 plus 1.5, or 15.5, and then 15.5 plus 1.5, that's going to be 17, And then 17 plus 1.5 is going to be 18.5. Sorry, I'm running out of room here. And then 18.5 plus 1.5 is going to be 20. So my four terms are 15.5, 17, 18.5, and 20. Here we're looking at this arithmetic sequence. So we have 3 to negative 10, negative 10 to negative 23, and negative 36. So we need to think about this particular sequence. And the first thing we're going to do with it is write an equation for the nth term of the sequence. So back to the beginning where we had the equation. The equation we're using is a sub n, which is what we're finding. That's the nth term. Then we have a sub 1. That's going to be our first term of the sequence. Then we have plus n minus 1. Remember, n is the number term that it is, so like the first, second, third, fourth term, which we're not asked to find. So we need to leave that the way it is. And then we have d, which is the common difference or the pattern. So we can fill in most of these to figure out the nth term. So we need to look at the first term, which is 3. That's going to go in for a sub 1. Then we have plus n minus 1, which we don't know the actual nth term, so that's why we keep n the way that it is. And then d is our common difference or pattern. So we need to figure out how we got from 3 to negative 10. So if you think about that, if you subtract 13, you would get from 3 to negative 10. And then if you keep going, negative 10 to negative 23, you're also subtracting 13. And then finally, you're subtracting 13. So the pattern, or the difference, is negative 13. Notice it puts negative because it's subtracting. If it's addition, you're just going to leave that as a positive. So then we can simplify this a little bit by distributing the negative 13 to the n and the minus 1. Oops. And we take negative 13 and multiply by both. So we have a sub n equals 3 plus negative 13n plus 13. And we can again simplify a little bit more because 3 and 13 are like terms, so we're going to add those left to right, 3 plus 13. So our final equation is going to be a sub n equals 3 plus 13 or 16. And then we can either say plus negative 13 or just minus 13n. And we can't combine those two because those are not like terms. So this would be my equation. Then I need to use that equation to figure out the 15th term. So we left n blank because that's the nth term. So we're going to plug in 15 for n now. So we have 13 times 15, which is 195. And we're going to subtract this from 16, which gives us negative 179. So our nth term, or in this case our 15th term, is negative 179. Now we're going to graph the first 5 terms of the sequence. So when you're graphing, usually we think of x comma y, but when we have a sequence, it's going to be n comma a sub n. So if you think about the first term, it says the first 5 terms. Our terms are 3, negative 10, negative 23, negative 36. Oops. Now we could do negative 49. So that's the first 5 terms. And we need to graph those. So our first term is considered 1, the first one. Then we have 2, 3, 4, 5. So that's the number of each term, and that's going to make up our ordered pairs. So we have 1, comma, 3. We have 2, comma, negative 10. We have 3, comma, 23. 4, comma, negative 36, and 5, negative 49. And we can actually make a table out of this. So these are our x's technically, and these are our y's. And if I were to graph those, I would need to build my graph. And I need to figure out a good scale, so the x values can just go by ones. But my y values jump quite a bit. We go all the way from positive 3 to negative 49. So I would say maybe even just going by 13 would be alright. Let's say negative 7. We'll say that. So by 7s, so that's our scale. Now we just need to plot our points. I'm going to use a smaller pen here, but our first point, if we go back, is 1, 3. So I'm going to go over 1 and up 3, which is going to be about in the middle here if I'm going by 7s. So we're going to put a point there. Then we're going to continue. We have our second term, which is negative 10, so 2, negative 10, which is going to be about in the middle here again. And 3, negative 23. This would be a little bit closer to the 21. But about there. And then 4, negative 36, which is going to be about here. And finally 5, negative 49. What you should see is that this makes a straight line. And we would connect the dots. To graph my equation. And then finally, which term of the sequence is negative 114? This one we're going to use our same formula. Okay, so our first number in the sequence was 3. We don't know n. And we know our difference, common difference or pattern is negative 13. This, we're asked to find what term or what number term, so the first, second, third, fourth, fifth, and so on, what number term negative 114 is. So this time I'm going to put in negative 114 in for a sub n and solve for n. So I get negative 114, and then again I'm going to distribute. So 3 plus negative 13n plus 13. Then I'm going to combine like terms on the same side, so that's 16 plus negative 13n. Then I want to combine like terms across the equal sign, so I'm going to subtract the 16. It's going to give me negative 130 equals negative 13n, and then I'm finally going to divide by negative 13 to get n is positive 10. So the number negative 114 is the 10th term in this particular sequence. And that concludes our lesson for 3-5.